Hello my dear students. Now we will discuss about a problem which is related to amplitude modulation. So in this problem, first of all we would discuss about the modulation. There is a modulating signal MT and there is a carrier signal CT. Here you can see, and we have to find out the modulation index, carrier power, and the power required for transmitting amplitude modulation wave AM wave. So that you can see when the solution starts. So there is a given equation, the equation of modulating signal as mt is equal to that is, and that is the standard equation of modulating signal is like that. So first of all we have to set the standard equation of a modulating signal, that is mt am cos twice by fmt. To find out what is the am and what is the twice by fmt, so find out the fm. From the twice by fmt you can get the fm is analogical to 10 to the power 3 hertz, that means 1 kilohertz, and am is 10 volts. First of all find out these two things. So we get the frequency modulating signal and the amplitude modulating signal, and the frequency and the amplitude of the modulating signal. Then the carrier signal CT, it should have to be compared to that kind of signal, that is CT AC cos twice by FCT. By this we get the 50 volts, that is the AC, that means the amplitude of the carrier signal, and the frequency of the carrier signal is FC 10 to the power 5 here, 10 to the power 5, and you know that carrier signal frequency is quite higher than the message signal, or what we want to transmit, modulating signal. Now that is the formula of modulation index, that is mu. uh, some In some books that is been denoted as m, some books that is denoted by mu. That is the amplitude modulation, amplitude of the modulating signal divided by the amplitude of the carrier signal. So after dividing that we get the mu, that is 0.2. So we get the modulation index 0.2, and that means the percentage modulation is 20%. That means there are 20% modulation in the signal will occur. The formula for carrier power is Pc is equal to AC square divided by twice R, and if we assume R is equal to 1 ohms and AC, as you know, that is 50 volt, we will find out the power Pc carrier power is 1250 watt, and that is therefore the carrier power is 1250 watts. Now if we want to find out the formula for power required for transmitting AM wave, that is PT is equal to, that means transmitted power is equal to carrier power. The formula of carrier power is PC 1 plus mu square by 2, and that is substitute PC and mu, that means the modulation index. In that part we get the transmitted power as 1275 watts. Then that the power required for transmitting AM wave is 1275 watts. In the problem 2, in this problem there is an equation, the total equation of an modulated amplitude wave that has been given, and we have to find out the carrier power and total sideband power and bandwidth of that AM wave, amplitude modulation wave. So first of all we have to just carry out that equation by providing such a equation to a standard level. That means we have to compare it with this standard amplitude modulated wave that we read on our book, that is AC 1 plus mu cos twice by fmt and cos into cos twice by fct. So into cos by fct there is a 4 pi into the power 5. We just split this value with twice by 2 to 10 to the power 5, and here twice by 10 to the power 3 t. After that, by comparing the above two equations, we get the certain values of AC, that is the carrier voltage, that is the modulation index 0.8, because we just compare these two in that portion. Then we will get the frequency of modulating signal FM, that is 10 to the power 3 hertz, that is 1 kilohertz, and the frequency carrier signal FC will be like that by just comparing these two parts, that is the 2 into the power 5, that means 200 kilohertz. After that the formula of carrier power PC is equal to AC square divided by twice R. We will just calculate it, just assuming the R, that means the resistance is 1 ohm, we will get 200 watt of the power. Then that is the carrier power 200 watts, but we have to find out the total sideband power. The sideband power theorem and the sideband power formula is PSB sideband, PC mu square divided by 2. Substitute PC and mu values in the above formula. In the above formula, if we just substitute these two parts, we will get like that. We will get just giving the point at point 8. We just put the value. We will get 64 watts. This total sideband power 64 watts. And we know the formula for bandwidth of AM wave is bandwidth is equal to 2 FM. Uh, that is the, what can I say, that is the twice of the modulating frequency, and we know the modulating frequency is 1 kilohertz, so the bandwidth will be the 2 kilohertz. That is the bandwidth of the AM wave. That's the brief analysis of the two problems related to amplitude modulation. Thanks for being with me, and hopefully you will understand these two mathematics, and uh, can perform this mathematics in any kind of competitive examinations. Thank you very much for being with me.